Hello dear friends, welcome to the lecture of numerical methods. We are studying interpolation. In the last lecture we have studied the Newton's or we have derived Newton's forward difference interpolation formula. And in this lecture we will solve the problems on Newton's interpolation formulae. But before that we shall derive the Newton's backward difference interpolation formula, and then these problems we shall solve. Earlier to that we will write a remark how to obtain Newton's forward difference interpolation formula using shift operator. So Newton's forward difference interpolation formula can be obtained using the shift operator E, as we have it is yn at x naught plus ph, and this can be written in terms of shift operator, that is y to the power p e to the power p of y at x naught. Now what this will operate e to the power p at y of x naught means, actually this will be y at x naught plus p times h. It takes p steps forward, and here h is the difference, common difference between the values of x. So actually we have defined e at y naught is equal to y1. It takes the one step forward, and that means shifts one step. E to the power 1 at y naught will be y1. This e means e to the power 1, and e square y naught will be y2. Or in general we have e power n at yr is equal to y r plus n. So it shifts n steps forward, and if this is p means it will take the value of y at x naught plus ph. Yn is in general written, so that means the value of y. So this is x naught plus p times h, that is e power p y at x naught, and y at x naught is y naught. The value of the y at x naught is y naught, so therefore we can write this as e power p at y naught. But what is e power p? E is 1 plus delta, that we have obtained the relation earlier. E is equal to 1 plus delta to the power p at y naught. And now we can expand this using the binomial theorem. 1 plus delta to the power p and operated on y naught. So we can write this is equal to 1 power p 1 plus delta to the power p. So what is the expansion of 1 plus delta to the power p? It will be 1 to the power p is 1 plus p delta plus binomial coefficients p minus 1 divided by 2 factorial o on delta square and so on, and this is operated on y naught. But this y naught must be remembered, and therefore we shall write in terms of y naught 1 into y naught, that is y naught, plus p into delta y naught plus p into p minus 1 divided by 2 factorial delta square y naught and plus so on. So then next term will be p minus 1 into p minus 2 divided by 3 factorial delta cube y naught, etc. So plus the next term will be this one, 3 factorial delta cube y naught and plus so on. So this is the Newton's same formula that we have obtained earlier. So this is a way to remember how to obtain the Newton's forward difference interpolation formula using the shift operator E. Now we will make use of this shift operator E to obtain the Newton's backward difference interpolation formula. Now that is our next result, Newton's backward difference interpolation formula. Here the differences used will be the backward differences, that is del. Why the word forward backward? Because the differences used are these type of and this delta is the forward difference, and we know this del is the backward difference. And here the value is obtained at x0 plus ph, and for backward difference we will consider the last value of x, that is xn, and we shall take the value of x as xn plus ph. So putting x is equal to xn plus ph, or taking x is equal to xn plus ph, where h is the common difference between the terms. So we have yn at xn plus ph. See the difference. Earlier we have obtained yn at x0 plus ph, and here we are obtaining for backward difference. This is first value and this is the last value. So that is the difference in forward and backward difference. Here the value is the last value of x, and this again can be written in terms of shift operator, that is e power p of y at xn, that is y at xn plus ph, p times h. So this is the same in terms of e power p, and but this e now we can write in terms of del. So this is equal to, so we have a relation that earlier, a relation between symbols that we have proved is del is equal to 1 minus e power minus 1, and from this what is e power minus 1, shifting this on that side, this is e power minus 1 is equal to 1 minus del, and if e power minus 1 is 1 minus del, what will be e power e only. So e will be this will be 1 minus del to the power minus 1. So that we shall write in terms of this, and this I shall write as 1 minus del to the power minus 1 raised to p of y at xn is yn. The value of y at x0 is y0, y at x1 is y1, y at xn is yn. So this is the expression for this value yn at x, which is xn plus ph. And now we have to expand this, or this will be, this is equal to 1 minus del to the power minus p of on yn, operated on yn. And now we can expand this using the binomial theorem. So what is the expansion of see 1 minus x to the power minus n? We can use this formula, and that is 1 plus nx plus, this will be n plus 1, you should check it, divided by 2 factorial x square, and so on. In place of minus for if there is these two are positive, then the binomial coefficients are n minus 1 divided by 2 factorial, but here it becomes plus because of both these signs are negative and every term is positive. So that is to be noted. You should verify this formula, and using this the expansion, and this is operated on yn. So this will be 1 times yn, that is yn, plus next will be n means here p into del, x is del operated on yn, plus next will be p plus 1 divided by 2 factorial and del square operated on yn, and likewise the next term will be plus the next term will be p plus 1 p plus 2 divided by 3 factorial del cube yn, and plus so on up to n terms we can write plus so on. So this is yn at xn plus ph. This is equal to the first value is yn, and this is the Newton's backward difference interpolation formula. So this is to be remembered. So we should remember this as the Newton's backward difference interpolation formula. So this is Newton's backward difference interpolation formula, where xn is, see, this x is equal to, or we can write, so this is Newton's backward difference interpolation formula, where here the value of x is, or this we have written earlier, x is equal to xn plus ph, and therefore from this p can be obtained. P is equal to x minus xn divided by h. So this is the Newton's backward difference interpolation formula. Now what is you may observe what is the difference in the forward difference and backward difference. One thing is that the for forward difference, it is the value at x naught plus ph, and for backward difference it is the value at this x is equal to x naught plus ph, and for backward difference it is the value xn plus ph. And for forward difference we use delta, and for backward difference we use del. P remains the same, but the binomial coefficients differ. In forward difference formula, it is p into p minus 1 divided by 2 factorial delta square at y0. Here at yn, and for forward difference it is y0. So that is the differences we have to note for forward difference and backward difference interpolation formula. And one note is to be considered as this formula is used. This formula is used to obtain or to interpolate. Interpolate means to obtain or to estimate the value at the end of the table, the value of y at or near the end of the table. The tabular values will be given. If the value to be estimated lies at near the end of the table, then we have to use, we shall prefer the backward difference formula. And earlier we have written the note also for forward difference formula. If the value is near to the beginning of the table or start of the table, then we use forward difference interpolation formula. So thus we have obtained both the Newton's forward difference interpolation formula and Newton's backward difference interpolation formula. Now we shall solve the problems which I have written earlier here on the board. Now we can see the first problem. The first problem is find the cubic polynomial. Find the cubic polynomial which takes the following values. That means the following values are y0 is equal to 1. The value at x is 0, then y is 1. So that is the y is function of x, means these values in bracket are the values of x. So when x is 0, y is 1. When x is 1, y is 0, means x1 is 1, y1 is 0, and so on. So these values are given, and we are asked to find cubic polynomial. So to find a polynomial is the problem of interpolation, and we shall obtain the polynomial, and further after obtaining the polynomial, using that polynomial or otherwise using the formula, we have to find the value of y at 4, y of 4. So this we have to obtain. Now first we shall consider the difference table. So solution for the first problem. We form the difference table. And difference table will be, of course, forward difference table. Though we want to use the backward difference formula, the table will be formed forward difference table, and we shall construct the table like as earlier we have seen. first column will be of x, and the values of x are, you may see these are the values of x in bracket: 0, then it is 1. We should keep space between these two values, because next we have to write the difference between the values of y here. So keep one line blank between these two entries of x and y also. So 0, 1, then 2, then 3. So these are the values of x. Now what are the values of y? The values of y are 1, 0, then 1, 10. So these are the values of x and y. Now we can write the value of the differences, delta, forward difference, and the difference, forward difference for the values of y, 0 minus 1, next value minus previous value, and 0 minus 1 is minus 1. So that is to be written in between these values. Then 1 minus 0, which is 1, in the column of delta, and 10 minus 1, which is 9. So this is the first differences. Then delta square. Now the second differences we shall consider by taking the difference of first difference, that is from the column of delta. So difference of this delta will be delta square, 1 minus minus 1, and that will be actually 2. So we have to write 2 here. And then 9 minus 1, which is 8. So this is delta square, second order of forward difference, second forward difference. And now next will be delta cube. Third forward difference is obtained from taking difference of second forward difference, 8 minus 2, which is 6. So thus we have obtained the difference table. So this is the difference table for the first problem. Now what we have to consider, we have to find the polynomial, and for that purpose we shall put x is equal to x naught plus ph, and that now the values we have written here. So therefore I shall remove this part and write here. y4 we have to obtain, we shall remember y at 4. And now we may have here as x is equal to, put x is equal to x naught plus ph. Now take x is equal to x naught plus ph. Here what is the x naught? X naught means first value of x, that is 0. X naught is 0. And what is see h? H is the difference between the values of x, that is always there. We have written xi is equal to x naught plus nh, and therefore h is the difference between the values of h, x, that is 1. Difference between the values of x, that is 1. So and thus we put these here, x naught and h in this, and therefore we have x is equal to x naught is 0 plus p into 1, or that is x is equal to p, or p is equal to x. So this is the value that we have obtained. Now we write the Newton's forward difference interpolation formula. Newton's forward difference interpolation formula, or forward interpolation formula. That is, Newton's formula is yn at x naught plus ph. X naught plus ph means x, and this is equal to, so we have written that earlier, that is first is y naught. So the formula must be remembered. First term is y naught, and next is p into delta y naught. Delta, not del, but delta at y naught. First difference at y naught. Next is plus p into p minus 1 binomial coefficients. this is 1, then p, and then p minus 1 divided by 2 factorial delta square at y naught. This is y naught, delta square at y naught. And next one more term is there, that is the third term, delta cube. And but what is the third difference? Third difference will be that will be here. So p minus 1 into p minus 2 divided by 3 factorial into delta cube y naught. So this is the Newton's forward interpolation formula. So this formula we have to use, and in this formula we have to put the values of p and these differences. Now what are the values of see, I have written here, the space is limited, but you should understand this is the formula. This is then our next problem. And in this formula, the formula is written, we have to put the values. What are the values? Y naught. So this is the value, first value of y is y naught, this is y1, etc. And this is y naught. What is delta y naught? Delta y naught is this value. The differences at y naught will be here. So this is delta y naught, and this is delta square y naught, and this is delta cube y naught. That means first diagonal values we have to use in the formula. So we can note these values. These values are to be used in the formula. This is 1, this is minus 1 in serial, in diagonal, according to the diagonal, and this is delta cube, delta square y naught, that is 2, and last is delta cube at y naught, that is 6. Now I shall put these values and rewrite this here itself. So this gives y at x or yn at x. Yn is the notation used, that is actually y at x, function at x, and therefore y at x is equal to y naught is 1 plus p value. So what is the value of p? We have x. P is x only, we have written earlier, obtained earlier, and delta y naught, that is minus 1, and plus p is x minus 1 divided by, so this is 2 factorial, which is 2, and whether it is visible or not, see to you, this is x minus 1 divided by 2 factorial delta square y naught is 2, and plus the next value is x minus 1 x minus 2 divided by 3 factorial. P is x, it is not 3 but 3 factorial, you have to correct it. 3 factorial, this is 2 factorial, this is 3 factorial. 3 factorial, which is 6 now, and delta cube y naught is again 6. So this value is 6. Now that can be simplified, and this becomes 1 minus x. Now we have used the formula and substituted the values in the formula, and you see that is 1 minus x, and this becomes 2 cancels, x into x minus 1, that will be plus x square minus x, and further this is 6 cancels, x into x minus 1, or we can multiply it by x and then to the product x minus 1 x minus 2, which will be x square minus 3x plus 2, and that can be simplified as 1 minus x plus x square minus x again plus x cube, this is x cube, minus 3x square plus 2x, or this is the polynomial is cubic. X cube term first we shall write. We will write the terms in decreasing power. X cube, this is minus 3x square plus x square, that is minus 2x square. And what are the terms of x? This is minus 2x addition and plus 2x cancels, and 1 remains, that is plus 1. So this is the required cubic polynomial that we have obtained. And further it is asked to find y at 4. Now y at 4 can be obtained by putting the value of x is equal to 4. So this is the required cubic polynomial. putting x is equal to 4 in it, we get, now if you put x is equal to 4 in this, what we shall get is y of 4 is equal to 4 cube minus 2 into 4 square and plus 1. Now what is this number that we can calculate? And this is 64 minus 32 plus 1. That is, this is 32 plus 1, which is 32. So this is the answer, y at 4. So two things we have obtained, and that are polynomial. One thing is polynomial, and second thing is the value of y at 4. Now you see, if without using the expression for the polynomial, the value of y at 4 can be obtained from the table. See, but 4 lies at the end, or that is actually outside this range, and for that case, instead of using the forward difference formula, we can use the backward difference formula and Newton's backward difference formula. Now for using the Newton's backward difference formula, we can take x as 4 and the value of xn is 3. Xn is 3, h will be the same, and these are the backward differences. This is the backward difference, del of y at del of yn. This is del square of yn, del cube of this is del of yn, this is yn, this is del of yn, del square of yn, and del cube of yn. That backward difference formula can also be used to find this y4. So it will be clear when we consider the example. In this example, we shall use the backward difference formula. Then it will be more clear to you. Now the solution for the second problem. Solution for 2. Again we form the difference table. The difference table is here these are the values of x and y. Now I shall consider the value of x here and then the values of y. So up to 9 values are we have to write. So, further this is the value of x are 3, then 4, 5, 6, 7, 8 and 9. So these are the values of x. So 3, 4, 5, 6, 7, 8. And 9. These are the values of x. Now the values of y are 13, 21, 31, 43, 57, yes, and 73, 91. These are the values of y. Now we should consider delta. Here you see forward difference table only we shall obtain for this one, delta. And the differences of y will be 21 minus 13. So that is 8 here. 31 minus 21, that is 10. This is 43 minus 31, that will be 12. And this is 57 minus 43, this is 14. Yes, and this is again 73 minus 57, that is 16, and 91 minus 73, see this will be 18. You should check it. These are the differences we have to write. So we have to keep some space here. And this is delta. What will be delta square? Delta square. Differences of the first order difference, that is 10 minus 8, which is 2. This is 12 minus 10, which is 2. This is 14 minus 12 is again 2, and this is also 2. Last is 18 minus 16 is 2. So these are second order differences. Now what about the third order differences? Because the second order differences are constant, the third order differences will also be constant. So this is 2 and 2. So this will be 2 minus 2, that is 0. This is also 0, this is 0, and this is 0. So the table ends here itself, because the next differences are going to be 0. Actually this we should not also consider cubic differences, because each is equal to 0. And thus this is the difference table for the given values of x and y. Now what is asked, you see, y is a series. These are the values in a series. That means third term of the series is 13, fourth term of the series is 21, and so on. And we have to find the first and 10th term. We have to find first and 10th term of the series, and also we have to find the polynomial which approximate these values. So that is asked. So first term and 10th term of the series is asked. So because we will remember, to obtain first term and 10th term of the series, the data is represented in the table. So therefore I shall remove this problem. We have written this data in the table, and 10th term, first and 10th term we require to find. And see, to obtain the first term, which formula we should use, forward or backward interpolation formula? First term is close to the beginning values or end values in the table of x values. So this is third term, this is fourth term. First term is actually earlier to the table, tabular values, that is given values earlier to the, and therefore we should use the forward difference interpolation formula, Newton's forward difference interpolation formula. And therefore to find the value at x is equal to 1, we should take x is equal to 1, or first we should write here what are the values of what is value of x naught? X naught means the given value, starting value, that is 3. X naught is 3. And what is the h? H is equal to the difference between the values of h. Equally spaced values of x we are considering up till this interpolation formula, and therefore the difference between the values of x is 1, 3, 4, 5, etc. So that is h is 1. And what we have to consider is to find the value at x is equal to 1. In the problem it is asked to find the value of at x is equal to 1, first term and the 10th term of the series, this series. These are third to 9 terms are given. We have to obtain 1 and 10th term. So take x is equal to 1. We use Newton's forward difference formula, and we have x is equal to x naught plus ph by first forward difference formula, and that gives what is the x is 1. So therefore it is 1 is equal to x naught is 3 and p and h is 1. So putting these in this. So this is the value of x for forward difference interpolation formula that we have to remember. And what this gives, the value of p is, therefore p is 1 minus 3, that is minus 2. So thus we have obtained p is equal to minus 2. And now we write the Newton's forward interpolation formula by Newton's forward interpolation formula. What we have is yn at x. X is 1. Yn at x, that is x or x naught plus ph. X naught plus ph means x and x is 1. This is equal to, the first term is y naught. And the formula, though it is lengthy, not difficult to remember, the first term is y naught, and next is p into delta y naught, and next is binomial coefficient p into p minus 1 divided by 2 factorial delta square y naught, and the third term will be p into p minus 1, etc. But that actually need not to write, because delta cube becomes 0. So therefore only these terms are sufficient to write, and we are using the forward difference formula, and therefore we have to use these values. X values are not x value is used on earlier here for x naught. X naught is 3, and the values from y naught are to be used. 0 actually we will not consider, because it gives the 0 value for the next terms onwards, and therefore these are the values to be used: y naught, delta y naught, and delta square y naught, and that gives yn at 1. So or that is simply y at 1. Y at 1 we have to find out, and y naught is 13 plus p is minus 2. Minus 2 into delta y naught is 8, and plus next value will be p is minus 2 minus 1, that is minus 3, divided by 2 factorial is 2. Delta square at y naught is 2, and it is easy to find this value: 13 minus 16. Here it is positive, 2 cancels, plus 6, and thus this is 13 plus 13 minus 16 is minus 3 plus 6, that is 3. So y at 1 is 3, and therefore when x is equal to 1, or the first term of the series is is 3. First term of the series is 3, that is y at 1 is equal to 3. Now it is asked to find the 10th term of the series. Now how to obtain the 10th term of the series? For that purpose, see, we should use the Newton's backward interpolation formula, because 10th term lies at the end of the near the end of the table, and therefore we shall use the backward difference interpolation formula. How to use the backward difference interpolation formula? For that purpose, next to find see, next xn is actually the value of xn is means this value, that is 9. Xn is 9, last value. And what is h? H remains the change. H remains the same for forward or backward interpolation formula. And here we have to take x is equal to 10, because we want to find the 10th term of the series, and we have the formula for x is equal to xn plus ph. Instead of x naught, we are taking now the value at end of the table, xn, that is 9 of plus ph, and thus this becomes x is equal to 10. See this, and xn is equal to 91. No, x is 10, xn is 9. Xn is 9, the value of x, last value of x, that is 9, and p into 1. So what that gives the value of p? P is now 10 minus 9, that is minus 1. So, and now we use Newton's backward interpolation formula. Backward interpolation formula. Now see, what is the change in backward interpolation formula? That is yn at x. X means 10 here. X value is to be obtained, that is 10. And what is here? Instead of y naught, we have to write yn. This is yn, and this instead of delta, we have to write del. So this is del yn, del at yn. And now what change in the binomial coefficient? That is p in place of binomial coefficient. Here the coefficients will be p into p plus 1. divide by 2 factorial, and that is again del square yn. You observe the Newton's backward difference interpolation formula that we have expressed. The starting term is yn, next is p delta yn plus p plus 1 divided by 2 factorial delta square yn plus p into p plus 1 into p plus 2 divided by 3 factorial del cube yn. But we are not writing further terms because only the second differences becomes constant. Third and onward differences will be 0. So by observing the table, how much differences are there non-zero, up to that we have to write the extension of the formula. And now we will put these values. Now while putting these values, you see y at 10, what are the actual values from the table? These values are at the end of the table, yn. So this is the value of yn, and that is actually y9, and then del yn is this value. Backward difference at the end will be these values. 0 we will not consider, and therefore these are the required values. So for forward difference we use these diagonal values, and for backward difference formula we use these values at the end of the table. Again these are also diagonal. So this is del, this is yn, this is del yn, this is del square yn. So these are the corresponding values, and that is yn is 91 plus p is minus 1, del yn is 18 plus p is minus 1, and next value is minus 1 plus 1, that will be this is whether the value of p we have written correctly, that we should note. 10th value is asked, and this is x is equal to xn plus ph. X is 10, 9, p into 1, so p is minus 1, so this is becoming 0. P minus 1 plus 1 divided by 2 factorial, and del square of yn is 2. So thus this value is 91 minus 18. 91 minus 18, or so this is the value that we are obtaining, 91 minus 18, so which becomes say some 73. But why this is becoming 0? So it is p into p plus 1 divided by 2 factorial. So something is wrong in this value of obtaining or writing the value of p. So we shall check it again. Yn is 9, xn is 9. Xn is 9, that is 9th term of the series, 3, 4, 5, 6, 7, 8, 9. And then h is 1, that is right. And what we have to write is x is equal to xn plus p times 1. X, the 10th term we have to obtain, that is 10 is equal to xn is 9 and plus p. So it is not minus 1, but it must be plus 1, so it is to be corrected. So this is p is 10 minus 9, which is plus 1. So we will have to correct this, and this is 1, this is 1, and this is 1 plus 1. So this is the correction. Please note this, we have done mistake in writing the value of p. This is p is 1, and thus now it becomes 1, 1 plus 2. This is 91 plus 18, and this is 2 cancels, 1 into 2, that is again 2, and thus this value 20 plus 91, it is 111, and this is the value of y at 10, yn at 10. So 10th term of the series is 111. So thus we have obtained the 10th term of the series. This is the 10th term. of the series. This is the 10th term of the series. And now what we shall have to obtain is the polynomial actually. So this is the 10th term, you should note. And to find the polynomial now. To find the polynomial, we can use the forward difference formula. To find the polynomial y at x. Say we put x is equal to, take or put x is equal to x naught plus ph. And what is x naught? X naught is 3. 3 plus p into h is 1. And therefore what is p? This gives equate the first and the last. X is equal to 3 plus p means p is equal to x minus 3. And we have to use these values in Newton's forward interpolation formula. So Newton's forward interpolation formula is forward interpolation formula. Y at x or yn at x is equal to y naught plus p into delta y naught plus p into p minus 1 divided by 2 factorial delta square y naught. That is sufficient here. Third difference is 0. Now what is the change in obtaining polynomial and the particular value? Here we have considered x as x and p is written in terms of x. Earlier we have put x is equal to 1 and at the last taking x as xn we have put x is equal to 10. You should note these steps and these the differences in these obtaining the values of polynomial and particular point. So yn at x is equal to y naught is 13. The same values we have to use 13, 8, 2 and p, but p is different. P is x minus 3. So x minus 3 and delta of y naught is 8 plus x minus 3 into x minus 4 divided by 2 factorial which is 2 and delta square at y naught is 2. So that is 2. So this cancels and what remains is 13 plus 8x minus 24 and plus the product of these two, x square minus 7x and plus 12, or that is, this is equal to x square plus 8 minus 7, that is plus x, and what is the constant? 13 plus 12 is 25 minus 24 plus 1. So this is the required polynomial. This is the polynomial. You should check the values that we have obtained, or all the tabular values must satisfy this. That is, y at 3 must be equal to 13. Put x is equal to 3. This must be 13. 3 square 9 plus 1 10 plus 3 13 and so on. Y at 1 we have obtained, that is 1 plus 1 plus 3. 1 plus 1 plus 1, that is equal to 3. Y at 10 also we have obtained, 10 square, that is 100, and plus 1, that 10, 100 plus 10 plus 1, that is 111. So that means these values are satisfied. And we should note that when we obtain the values outside the range, given values in the table, outside the range of the tabular values, then that is called extrapolation. And if the value lie between in the range 3 to 9, and that estimation is called interpolation, and the value outside the table is extrapolation. But whenever we can fix a polynomial, then the interpolation and extrapolation will give the same result. So thus in this problem we have used both the Newton's forward difference formula and Newton's backward difference formula. Newton's forward difference formula for obtaining the value of the series at x is equal to 1, backward at x is equal to 10, and to obtain the polynomial we have used the forward difference interpolation formula. So in this way we can use the Newton's forward and backward difference interpolation formula. Now the problem number 3 and 4 I have written here for you to solve. So please try to solve the third and fourth problem yourself. Here the population of a town is given after 10 years, each 10 years, starting with 1891, then 1900, 1, etc. So these population figures are in thousands. This is 46,000, etc. It is written here, but we shall consider only these as 46, 66, etc., and that is to be multiplied by 1000. So what is asked is estimate the population for the year 1895. So form a table, difference table like this: the value of x, the value of y, then form the delta square, delta cube, up to the last entry must be 1, and form the table up to that values. And then for 1895 this will lie at the beginning of the table. Here it is interpolation. It will lie between these two values, and use for this forward difference interpolation formula, and this value 1925 will lie in between this, and for that use the Newton's backward interpolation formula, and these will be the answers. So you check the answers by solving the problem. And the last one is exactly similar that we have just solved here. Series is given, and we have to find again the first and 10th term of the series. In place of these values, decimal values are given, and it is preferable to use calculator. So here the figures are integers, but sometimes the figures will be decimals or more than one decimal, that 2.713 may be like this, and therefore it is convenient to use the calculators. So use calculator for obtaining the difference table of this, differences in this, and solve the problem exactly similar to the second problem that we have solved. So this is about the problems on interpolation formula. Remaining part we will continue next time. Thank you.